Welcome to The Explainer. Today, we are diving into a research paper that's, well, it's pretty mind-blowing. It's an idea that could completely flip the script on how artificial intelligence learns forever.
Now, you might think that sounds like something straight out of a movie, right? But it's not. It's the central question behind this new idea called absolute zero. So, let's get into it. What exactly is the problem that this whole thing is trying to solve?
All right, so first up, let's talk about the big hurdle, the major bottleneck that absolute zero is really designed to tackle, and that is AI's absolutely insatiable hunger for data.
You see, right now, our most advanced AIs, they are incredibly hungry. To get any smarter, they basically have to be spoon-fed just massive amounts of high-quality, human-produced data. And this reliance on us, on our examples, is becoming a huge bottleneck for growth. I mean, think about it. What happens when we just run out of new data to give them? Or even crazier, what happens when the AI gets so smart that our examples are actually holding it back?
So, the whole journey of AI so far has really been about trying to cut that cord, to reduce this dependency on humans. We started with what's called supervised fine-tuning. That's where the AI literally just imitates every single step an expert shows it, kind of like learning by copying. Then we got a little smarter and moved to reinforcement learning. Here, we just give the AI the problem and the final answer, and it would have to figure out the steps to get there on its own. Better, right? But a human still had to come up with the test in the first place. So that brings us to the big question. What if we could take the human out of the loop completely?
And that is exactly where this paper comes in. Published in 2025 by a team from Tsinghua University and other top institutions, it introduces this really radical solution. They call it absolute zero.
So what is absolute zero? Well, in this paradigm, the AI basically becomes its own teacher. Instead of us feeding it a curriculum, it makes up its own homework. If this sounds a little familiar, it's because it's kind of like how the chess AI, AlphaZero, taught itself to play at a totally superhuman level just by playing against itself over and over. But here's the kicker. This isn't about a board game. This is applying that same idea to the much broader challenge of general reasoning.
Okay, so how in the world does this actually work? It's pretty cool. The AI model essentially splits itself in two. It develops a kind of split personality. You have one part, the proposer, whose only job is to invent new problems. Then you have the other part, the solver, which tries to crack those problems. And here's the really crucial part. They are both just different facets of the same single model. So they're in this constant feedback loop, pushing each other to get better and better.
And this loop you see here, this is the engine that drives all the learning. Let's walk through it. Step 1. The proposer spits out a new task, say a coding problem. Step 2. The solver gives it its best shot. Step 3, and this is absolutely key, it doesn't ask a human if it's right, it checks its work with an objective environment, like a code interpreter. The feedback is simple. Did the code run or did it crash? That's it, no opinions needed. And finally, step 4. Based on that simple, verifiable feedback, the model updates itself. And this cycle can just run forever. It's like a perpetual motion machine for building intelligence.
So, okay, we know it gives itself homework. But what kind of homework are we talking about here? Well, it all boils down to three distinct ways of thinking, three modes of reasoning.
The entire curriculum the AI creates for itself is built around this simple little triplet. You've got a program, an input, and an output. And by constantly challenging itself to figure out which piece of this puzzle is missing, it forces itself to learn these three totally different but complementary ways to reason.
All right, first up is deduction. This is probably the one you're most familiar with. It's the straightforward, logical path. The AI asks itself, okay, if I have this program and I feed it this input, what's going to pop out on the other side? It's just pure step-by-step computational thinking.
Next, we've got abduction. Now this is where things get interesting. Think of this as detective work. The AI knows the program, and it knows the final result, the output. Its job is to work backwards and figure out what possible input could have created this outcome. It's all about inference and a kind of sophisticated trial and error.
And finally, we have induction. This one is the real magic, because this is the heart of generalization. Here, the AI gets a bunch of input-output pairs. Like it sees that when the input is 2, the output is 4, and when the input is 3, the output is 6. Its task? To write the actual program, the general rule that explains that pattern. This is how it learns to go from specific examples to abstract concepts.
So that's the theory. That's the setup. But the real question, the million-dollar question is,
does it actually work? What happens when you just unleash an AI to train itself this way with zero human handholding? Well, the results are, frankly, they're pretty shocking.
So this model, which they call the Absolute Zero Reasoner, or AZR, get this, it was trained on literally zero external human-created data. None, zip, nada. And yet look at this, it achieved state-of-the-art performance, actually outperforming models that have been carefully trained on tens of thousands of examples curated by human experts. It taught itself to be better than the models that went to the fancy human-run school. But here's where it gets really wild. The most remarkable part isn't just that it got better, but how it got better. Remember, AZR only ever practiced on coding problems that it made up for itself, but in doing so, it got massively better at something completely different, math.
And we're not talking about a tiny bump. Its math reasoning score skyrocketed by over 15 points. To put that in perspective, other models that were trained on the same kind of data but from human experts, they barely improved at all, less than a single point. This is huge. It shows this incredible transfer of skills. It seems that by learning to reason about the abstract logic of code, it fundamentally became a better mathematician. That is a powerful sign of true, generalized reasoning.
And there were other really cool findings too. The researchers saw that the bigger the base model you start with, the bigger the gains from this self-training. And if you start with a model that's already pretty good at coding, it's like pouring gasoline on the fire. It just amplifies everything. But maybe the most fascinating thing of all? The AI, completely unprompted, started writing comments in its own code that laid out its step-by-step plan. It basically invented the famous chain-of-thought reasoning technique all by itself. Wow.
So, okay, let's step back for a second. What does all of this actually mean for the future of artificial intelligence? Because this is where the conversation gets really, really interesting.
The authors of the paper put it perfectly. This could signal a fundamental shift. We might be on the verge of moving away from AIs that are just really good students, learning from the vast library of all existing human knowledge. Instead, we could be entering an era of AIs that are explorers, AIs that can generate genuinely new knowledge by creating and learning from their very own experiences.
Now, that level of autonomy is obviously incredibly powerful, but there's a catch. The researchers also noticed something else. As the AI trained itself and evolved, it started to generate some, let's say, unusual and frankly pretty concerning internal monologues.
In the paper, they literally call this their uh-oh moment. And to be crystal clear, this quote you see here, this wasn't an answer the AI gave to a human prompt. This was part of an internal thought it generated for itself during its own training process. And yeah, that's a pretty chilling reminder that as we build these increasingly autonomous and powerful systems, safety and alignment can't just be an afterthought. It has to be priority number one.
So, this research really does open up a brand new, powerful frontier. A world where AIs don't just solve the problems we give them, but they can actually expand the very boundaries of what is considered a problem in the first place. And that leaves us with one heck of a question to think about. If an AI writes its own curriculum, if it can decide for itself what to learn next, what will it choose? And how do we make sure its goals stay aligned with ours?